Okay, we are recording. Yes.
Can I go to my water?
Yes. We're doing constructions. Welcome to everyone that might be watching this video. Welcome to you, fourth period. Yesterday we talked about the construction of how to copy a segment, and today we're going to take a look at copying an angle. That's our topic for today. So, blank sheet of paper, construction number 2. Let's label it and let's get rolling. All right, well, before we do the actual mechanical steps of copying an angle, we've got to get some terminology. Okay, so let's just take a look at a random angle here. It's made up of 2 rays. Does everybody see the ray? Here's the end point. There's a ray going that way, and there's a ray going that way. 2 rays, and they intersect at a unique spot. We call it the vertex. So this point right here where the 2 rays endpoints are coinciding, that is called the vertex. So we have a ray up here, we have a ray down here. The amount that the rays are separate is the degree measure of the angle. An angle is usually denoted with a little angle symbol. That is not an L. It kind of looks like an L, doesn't it? But it's not an L. It's an angle symbol. And so if this were a letter right there, we would call this angle A. That's how we pronounce it. That's how we denote it. Angle A at the vertex. Sometimes we can use 3 letters. So let's say there's a random point out here, M, and there's a random point out here, we'll call it N. And so we can have angle M-A-N. Whenever we have 3 letters to denote an angle, the middle letter is always the vertex. Always and forever. The middle letter is always the vertex. Okay, we good? All right, we are going to now move into the mechanical steps of copying an angle. In order to do that, we have to start with an angle. So go ahead and use your straight edge and start with an angle. Does not matter if it's acute, obtuse, right. The only other type of angle is called a straight angle. We don't really copy that one because it's just a straight line. So I'm starting off with an acute angle, as you guys can see. Somebody out there tell me, what's the difference between acute and obtuse? Allie?
Acute is under 90 degrees and obtuse is
Excellent. Acute, less than 90 degrees. Obtuse, greater than 90 degrees. Mia, what's the right angle?
90 degrees.
Equal to 90 degrees. There's a tougher question for you. Let me see. Who can I ask a tougher? Natalie. What's the degree measure of a straight angle? Nice guess, but no. 180. So a straight line's 180 degrees. Okay, so now here is our angle. Anytime that we're going to copy something, we need a ray to copy it onto. Okay, now let's get our compass out. Let's go through the mechanical steps of copying the angle. We are not using our protractor, only our compass. Here we go. You ready? All right, so we put the sharp point at the vertex, and this can be wide to any width. It does not matter. All right, so I'm going to keep it to that width right there, and then I make an arc that intersects the angle at both rays. Don't let the compass move on you. And then I move it down, and I make the same arc with the sharp point at the end point. All right. So all I've done is use the same width and created two arcs. Now, go ahead and highlight the points of intersection between the arc and the ray. There's two of them here, and there's one of them here. We're going to use those points now. I like using different colors just because it stands out a little bit. All right, now, don't do this. This is cheating. Don't go to your compass and say, ooh, that looks like it's 60 degrees. And then I come down here and go, 60 degrees. I don't do that. That's cheating. Okay, so I use my compass to find the distance between these 2 points. So I'm going to put my sharp point on this point of intersection. Oh, too short. This is me playing basketball with Caden Randolph. As I dunk over top of him, I would look down at him and say, too short. As the ball goes through the net and hits him on the forehead. Too short. So I got to widen it out a little bit. There we go. I like to be precise. Make sure your compass doesn't move off the points. There we go. Perfect. Now, look where it goes. I'm going to move the compass down to the ray. Don't go from the end point. Don't make that mistake. Go from the point of intersection between the ray and the arc. And I'm going to make the same arc that I made up here. Now that arc, those two arcs create a point of intersection. I'm going to highlight it. I'm going to accentuate it. I'm going to put a point there. Now I go to my straight edge and I connect the end point to that point of intersection. Voila! I've just copied my first angle. Allie, did you follow it along all right? All right, let's do it again. This time, I'm going to use an obtuse. So I'm going to create an obtuse angle. And I'm going to copy it on a vertical line. Vertical ray. Okay, so I'm going to go obtuse angle, copy it. All my steps remain exactly the same. This is just the setup of the construction. Here we go. I'll go a little quicker this time. If I'm going too fast, slow me down. So I go to the vertex. Any width on my compass doesn't matter. I'm going to go a little wider for no reason, just because I can. Make a big arc. Keep that compass the same. Go down to the end point now and make another big arc. I went to the two arcs. Okay, now I like to highlight, I'm going to use a different color just so it stands out. I like to highlight the point of intersections. Not all teachers do this. I think it's helpful. So I've highlighted the 3 points of intersection. Hallie, can you see it? If you need to move up to the front, you can. I don't want you to hurt your neck as you're trying to look around people. Alright, so now I'm going to use my compass and find the distance between the 2 points of intersections. Too short. Sometimes I say that to Natalie as she putts. You hit it too short. A little wider. I want to be precise. There we go. We don't want to say, oh, it's good enough. Good enough is the phrase for mediocrity. Oh, it's good enough. No, it's not. Let's be precise. Don't let your compass slip on you. You know what? I'm going to make sure my compass didn't move. I'm going to go back and measure it again. Yep. All right, we're good. Don't go from the end point. I go from the point of intersection on the ray. Hallie, does that make sense? Okay, and then I'm going to create a point of intersection out here. See that point of intersection, Hallie? All right, now I'm going to highlight it just because it makes it easier. Good. Use a straight edge now and connect those 2 points. And there's my other ray. This angle and this angle are the same. Any questions? That's 2 that we've done now. Ty, you got it? Okay. What if we wanted to go ahead and do 2 times angle it? I think I got room over here. I can squeeze it in. Let's go ahead and go back and give ourselves an angle. I'm going to make it look like this time. All right, we're going to call that angle A. And now I want to copy angle A so that my resulting angle is 2 times angle A. Anytime I'm going to copy, I want to start with a ray. I'm going to go backwards this time, just to show you that things don't change. Abby, we good? All right. So here we go. Use the compass. I'm going to go a little quicker. If I'm going too fast, slow me down. We go to the vertex. Put the sharp point on the vertex. Make an arc. Try not to let your compass move. Go over here to the end point and make the same arc. I'm going below it this time, doesn't matter. Highlight the points of intersection. Let me use a different color. We'll use red. 1, 2, 3. 3 points of intersection. I'm going to use the compass to find the distance between the 2 rays. Too short. Ah, there we go. We don't want to say good enough. That's the voice of mediocrity. We also don't want to stress about it that we can't sleep about it, but we want to do our best. So then we come back here and put that on, not on the end point, but on the point of intersection. And we create another point of intersection with another arc right there. Let's highlight that point. Connect it with the straight edge to the end point, which now becomes my vertex. All right, we just copied one angle A, correct? But I want two angle A's. But I only have one. I'm just going to do it again. This time I'm going to do it above the ray. And so I'll have one A and then a second A. Here we go. I'm going to go a little quicker. On the vertex, go narrow, arc, intersection, endpoint. Highlight. Find the distance. Sometimes when it's real narrow, I think it's harder to use the compass. Find the distance, copy it. Right here, highlight, connect to the vertex. All right, so I've copied the angle twice. So that means from here to the vertex to here, that is 2A. Okay, so that makes sense? All right, we're going to move on to another type of problem. Everyone okay? All right, let's just say now that I have an acute triangle. Go ahead and draw an acute triangle. And I want to copy two angles. All right, so anytime I want to copy, what do I got to start with? Array. Does array have to be horizontal? No. Array can be anywhere. Anyway. All right, so I'm going to copy an angle. I'm going to copy this one first. Arc. Don't let the compass move on you. AJ, you doing all right? Arc. Highlight points of intersection. Should have used red. Find the distance between the 2 points. Too long. Too big. Oh, excuse me. Put that on the point of intersection. Don't put it on the end point. Put it on the point of intersection. Get a new point of intersection out here. Highlight the point of intersection. Connect the dots. Okay, there's one angle done. Now, I'm going to go ahead and copy this angle right here. I'm going to do it right here. Here we go. I enjoy this stuff. Make a big arc. Do the exact same thing here. Big arc. Don't let the compass move on you. If you think the compass move on you, just go back and do it again. Highlight. I'm going to use red this time. Point. 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 Find the distance between the points. Ooh, a little short. There we go. That's closer. All right, then I go from this point. Don't go from the end point to this point. Highlight. Connect. the end point to that point. All right, now I have a question. Are these two triangles congruent? Do they look congruent? No, they are not congruent. But they are what we say, they are similar. Now let's just say that we're throwing numbers around and that this angle here is 65 degrees and this one here we just measure to be 60 degrees. Well, since we copied both of those got to be pretty close if we're precise at all. Those are 65 and 60. Does anybody remember what all three angles add up to be within a triangle? Tanner, do you remember? Very good, Tanner. 180 degrees. All three angles add up in a triangle. So if these two are 60 and 65, that's 125. So if I subtract, that means that this is 55 degrees. Everyone see my math there? So if that's 55, then doesn't this also have to be 55? So all three angles are congruent, but does that mean the triangles are congruent? No. It means they're similar. Could we make the triangles congruent with what we learned yesterday? Yeah. All we'd have to do is copy a segment in between the angles, which is something you might do on a quiz. By the way, we're setting up for a quiz for Friday. Quiz for Friday on the constructions we're learning now. All right, any questions on that triangle stuff? Okay, so let's do it again. But this time, we're going to do an obtuse triangle. So, obtuse triangle. Start off with a ray. All right, go ahead at your seat. If you feel confident, go ahead and do it. Those of you that aren't confident, follow me. Let's see, which one do I want to do first? Let's do the obtuse angle first. I'm going to go to the vertex, make an arc, any random width that intersects the two sides of the triangle. Go to my endpoint and make the same arc. Got to make it wide because this is a big angle. Highlight points of intersection. Use the compass to find the distance between the 2 points. Want to be precise, go to the point of intersection on the ray. Don't use the end point. Connect the point of intersection with the end point, which is going to become my vertex. All right, now I'm going to copy this angle right here. This is a small angle. Chase, you doing all right? All right, copy both sides, an arc, intersection, both sides. Over here, do the exact same thing. It can get confusing with all these arcs in here. Highlight them, use black. Find the distance between the two sides of the triangle. I think when they're smaller, it's harder. That works. Go to the point, don't go to the end point. That doesn't make sense. Okay, point of intersection. Here. Now I'm going to connect that with the end point, which becomes the vertex of the triangle. Same angle, same angle, same angle, same angle. It's a lot smaller triangle, isn't it? But I know that they are similar. All right, how are we doing? Not too bad? Could you do it on your own without me walking you through it? Yeah? No? Okay, here's what I want you to do. Start with a triangle. I'm going to stop the video here shortly. I don't care what the triangle looks like. Okay, and then see if you can create a congruent triangle. That means you've got to do two angles, and then one side has to be congruent. Once you make one side congruent, then you know you've got it. All right, those of you that are watching the video, we're going to stop it now. And any questions, send me an email.